Hello, ladies and gentlemen, and I hope you're all doing well. In this video, we're going to be taking a look at question number 5 on our grade 8 Gauss from the year 2010. The area of a rectangle is 12. So immediately in my head, I'm thinking 3 by 4. Although I guess after writing that, it could be something like 2 by 6. It might not even be whole numbers. Each of its side lengths is a whole number. Okay, it's going to be sort of one of these, although maybe it might be 1 and 12. There's a bunch of possibilities here. What is the smallest possible perimeter of this rectangle? Ooh, okay. So, well, the way I think we could probably go about doing this question is saying, well, 12 has 12 is going to be the area, right? So if we have sort of length and width, we can see that 12 is length times width. So both L and W need to be factors of 12. So what are the factors of 12? Well, there's 1 and 12. That's a nice pair. Sometimes it might be a good idea to sort of write them out like this. So 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, 12 is a factor, and just pairs of these multiply to 12. So we get 3 different rectangles. Now, if you continue on in math, you'll see similar questions to these every once in a while. And so you can write out all of these and then say, all right, what are the perimeters? Well, perimeters are just sums of side lengths, right? So we get 3 plus 4 plus 3 plus 4, or 2 times 3 plus 4. And that's going to be 14. Here we get 2 times 2 plus 6, so that's going to be 16. And 2 times 1 plus 12, because there's 2 1s and 2 12s. And that'll be 26, and we see 14 is the lowest, so 14 is our answer. But as I say, if you continue on in math contests, you see questions very similar to this every once in a while. I feel like there were a couple questions like this on a fairly recent Pascal. And it's a sort of a useful thing to know that if everything, if all things are equal and you have the same products, you usually get the smaller sum, perimeter in this case, if the numbers are as close together as possible. Okay? So, as soon as I had listed out the factors 1, 12, 2, 6, 3, 4, I already knew, because I've done so many of these, that 3, 4 was going to be the correct answer to have the smallest perimeter. Just like if you want the biggest perimeter, you want the numbers to be as far apart as possible, and that gives you 1 and 12 with a perimeter of 26. Okay? But the little things that you pick up, you can prove this mathematically using parabolas and other high school shapes or inequalities like the arithmetic mean, geometric mean, things like that. And that's fine. But it's just a nice little guiding principle or pattern that you can pick up and that I'm now passing on to you if you didn't already know it. Okay? So 14, I think we want what is the smallest perimeter, right? What is the smallest perimeter of this rectangle? And 14, and that is also the smallest possible answer presented. So we feel kind of good about that. And our answer is going to be D. Now, I really have run out of room. I kind of made the lettering too small here. But let's flip the page. And we got a nice, clean, fresh page for question number 6. And that'll be coming up in the next video. I'll see you there.